Hello, my name is Fayaz Rashpari, and today I will be demonstrating FireEye's Threat Analytics platform. TAP is an extremely powerful security and incident response platform, which can be augmented to any current SIEM deployment or used as a standalone security-driven cloud SIEM. In today's video, I will be going through a TAP demonstration through our intelligence on an attack campaign led by APT3. Before we start the demo, it's important to understand the key value props of TAP and its history. George Sanford from our deployment team will explain.
Hello and welcome to the FireEye Threat Analytics Platform, or TAP. My name is George Sanford and I'm a senior engineer with the FireEye TAP team. Before digging into the nuts and bolts of how TAP does what it does, it's important to understand the evolution of TAP and why we believe TAP is an essential solution for all enterprise, regardless of their current security practices. Developed by FireEye and Mandiant teams to address needs we identified as we were called to respond to critical breaches, TAP provides an efficient and powerful solution to better detect and respond to potential evil in even the most complex environments. In the changing threat landscape, adversaries have become more sophisticated and enterprise must adapt. Our opposition is proficient, highly motivated, well-organized, well-funded, and has at their disposal advanced and specialized tools. The security gap has drastically widened, and the defensive model that enterprises employed for decades is failing. We now live in a world where it is clear that breach is inevitable, and previously effective models no longer serve to protect us. In recent years, our experience has shown us that enterprise can take far too long to detect and respond to being breached. In many cases, professionals lacked necessary experience and tools that provided much-needed context and focus. Existing solutions were slow and delayed response, even when properly implemented. And many of the tools that were available were expensive, difficult to maintain, and didn't scale to meet new threats. Our capabilities needed to evolve, and we sought out a solution that could address specific criteria, dictated by our need to detect, understand, and respond to even the most advanced attacks. This solution must leverage not only the vast knowledge we had about threat actors and how they work, but also the rich data we already had in our environments. We needed less noise to reduce alert fatigue and generate high-fidelity alerts, not just more alerts. Beyond finding the indicators we could already know about, we had to add the ability to detect potentially malicious behavior that didn't rely only on signatures. We needed a solution that was fast, scalable, and could adapt as threats change, and even provide a platform for identifying new ways of detecting evil. And we had to find a way to maximize what even a small number of analysts could do by putting it under a single pane of glass, providing the resources, context, and tools they needed all in one place. Our solution was TAP.
Thank you, George. Now let's talk about the ease of deployment and architecture of TAP. The TAP architecture is quite simple and extremely easy to deploy. The solution is hosted in the cloud, and the only item that is deployed on the customer network consists of a thin network sensor called a cloud collector. This device collects a wealth of information from the network and can relieve you of the need to configure numerous high-priority log sources including firewalls and IDSs, as well as configuring other data sources that are critical to network security monitoring. The cloud collector can greatly enhance visibility to your network and allow an incident responder to do their jobs with great speed and tenacity. Since TAP lives in the cloud, it allows your security team to focus on real security events and not around management and upkeep of the platform. Users are provisioned by the FireEye Cloud team. Each user is enforced to sign up for two-factor authentication after they have been provisioned. Here you will see numerous FireEye solutions that can be accessed via the portal. This includes FireEye as a Service, FireEye Intelligence Center, and Threat Analytics Platform. The main dashboard of TAP is categorized into three main sections. We will start at the bottom. TAP can ingest data from almost any source you care to feed it. More importantly, the cloud collector will collect metadata from your network and parse results under each respective asset class and the protocols it's analyzed. Some other great examples of log sources can be web servers, VPN logs, Windows event logs, and even other FireEye logs. Every event is fed into TAP and examined against FireEye intelligence. When TAP finds a match, it triggers an alert and categorizes automatically based on a risk score. The platform works hard to eliminate alert fatigue while only giving you the stuff that matters. With Mandiant's intimate knowledge of victim networks, eyesight partners, in-depth knowledge of the dark web and attacker TTPs, along with our intelligence and detection teams behind this platform, we can keep rules up to date on a daily basis to stay relevant with the latest attack campaigns, attack groups, and threats. The FireEye threat detection team now has over 1,700 rules, consisting of millions of ILCs. The best part is that we are constantly updating these rules, adding, removing, and modifying so that your organization can focus on the alerts that matter and not get bogged down by creating and managing your own rules and intelligence. Now let's get into a TAP alert that identifies an advanced attack campaign and how we can go about quickly investigating this alert. Here's an alert on an intel hit based on a file hash. The alert details will provide me some context. In this scenario, it seems to be derived from a structured adversary. TAP goes far beyond this by the threat attribution done by our threat analysts. By going into the Intel tab, you will notice this alert is tagged APT3. This means that our threat analysts have successfully attributed this alert back to APT3 threat actor group. TAP has also identified some characteristics around a CVE and a detection of an exploit with evil intent. I can dig deeper into APT3 and get a full report created by your threat analyst. APT3 is a nation-state sponsored group operating out of China. We have details on who they like to target, what industries are affected, what countries are affected, along with their TTPs, from initial compromise to privilege escalation, reconnaissance, down to completing their mission. Let's search for that CVE. It looks like we've found some related articles even though we have zero results directly for the CVE, but if you see on the bottom, there are some recent articles. This article clearly identifies Operation Clandestine Wolf associated with the CVE, along with details on a zero-day used in the spearphishing campaign. After a quick glance on this article, I've stumbled upon some very good crumbs of information I can be hunting for in TAP. Here are some possible campaign phishing email senders. Perhaps we should look for a bad sender. Let's go back into TAP and hunt. Looks like we came back with some results very quickly. Search results in TAP are extremely quick and typically only take a few seconds to fractions of a second. TAP can scale from thousands to hundreds of thousands of events per second with the same speedy results. This allows an investigator to respond to an incident at scale without sacrificing on time. So let's take a look at the results that came back. Here we're seeing 12 results with the bad sender domain of ckonline.co.uk. You will notice the events are parsed with various fields that you can continually pivot or search and find additional information as you need. As an investigator, it may be important to understand the victim, username, and the machine name that is in question. Here we've highlighted the recipient, which is kminx@email.mandiant.com. Let's go ahead and search for kminx. Again, the results came back in 0.15 seconds this time. We can further pivot and see what else has occurred around kminx. If I click on the group by, I will be shown specific classes that kminx has traversed through. It looks like I've got Windows event logs, additional Intel hits, email logs, iron port, Mandiant MSO, otherwise known as HX, FireEye logs, and some unknown logs, all correlating back to kminx. Let's take a look at the Windows event logs associated with kminx. I can easily do this by pivoting on Windows event and adding to the current search. This will identify any association to kminx in my Windows event logs. I now have 1.4 thousand results in 0.16 seconds on all logs with kminx in my Windows event logs. This detail shows me additional parsed logs that are very interesting. I've got a hostname of victim A-1, some process creations, processes, file names, and process arguments. Let's do one more pivot and see exactly what process arguments I have under the kminx context. I could do this by issuing a group by field, which will give me all process arguments run under kminx in MS Windows event logs. All the results are shown on the left. However, I can easily table these results by clicking on the table icon. Immediately, I have now stumbled upon additional possible attacker commands that have been issued on the system under kminx identifies a scheduled task being run on victim A-1 at 12:36 along with a net use command to a victim 2 machine along with the username and password. This identifies lateral movement. If I move further down in the table, I see additional commands being run as well. With this level of detail, I can confirm that APT3 is in fact in my environment. This can be confirmed by seeing the net use commands, which were actually identified in the APT3 threat group profile, showing attacker tactics and procedures. Once I've identified important events, I may want to highlight these and create an incident. This allows for an easy workflow when other SOC operations and IR analysts are investigating, so that they may jump straight to the incident and begin where another incident responder may have left off. Once I add to the incident, I can then see this in the incident queue in the dashboard sections or under the response sections. Remember, once an incident is declared, then the alert will no longer show up under alerts. This is so another member of the security staff is not hunting down an event or an alert that does not need to be investigated. So to recap, let's take a minute to review. TAP allowed me to quickly jump to an alert that matters and get in-depth intelligence. I was able to get additional context on the threat group involved, the attack campaign, and the details used in the campaign, which I then was immediately able to leverage and hunt for in TAP. Lastly, my searches in TAP were extremely quick and provided time to value due to the infrastructure being hosted in the cloud with the ability to scale across hundreds of thousands of events per second. This concludes my demonstration of TAP. I hope you enjoyed it. Thank you and happy hunting.